All right, good day. This is not 1-2-1-16/17 exam past question. Question number 4. My question number 4 may not be the same in yours. Yours may be question number 10 or 12 or so, but the question will still be the same. So the question says, find the gradient of the normal to the curve x squared minus 4x plus 2y squared equals to 0 at the point at 0, 1. That's at x equals to 0, y equals to 1 at this point. That represents the coordinates. So we have to find the gradient of normal to the curve. Solution. Now, this question comes with the application of derivative, what we actually use it for. So we use derivative or derivative to find, we use it to find gradient of a line. Now, if you see this equation, this is a quadratic equation in which if you draw it, permit my line, it's not really straight. If you draw it in the plane, you have something like this or so. So they are now asking us to find the gradient of a line normal to that curve at this point. So assuming if this 0, 1, that's when you say y equals to 1 and x equals to 0. Okay, let's draw the graph like this. Okay, let me do some. At this point, okay, if your y is 1 and your x is what? 0. Your x is 0. So that means the curve is something of this nature. So this point is where they are talking about. So somehow it passes, somehow the curve passes that point. Okay. So now we have to find a normal. That means if you draw a normal to that line, to that point, a straight line that is at 90 degrees to that point. So they are now saying that we should find a gradient normal to that place. Now, before you find a gradient of a line normal to that point, you first have to find the gradient of a line that is tangent to that point. Take for instance, if you want to find a tangent to this point, I mean, you have to draw a line that's slightly, a straight line that slightly cuts that point. Then when you find the gradient of that straight line, that will give you the gradient of that particular point for the original graph. So now let's get to work. So for us to find the gradient of the normal, first we have to find the gradient of the tangent of a line that is tangent to x squared or to this quadratic equation. So to find that, we have to find the dy dx of this equation. That means we have to differentiate this. So if we differentiate that, that's d dx of x squared, close the bracket, minus d dx of 4x plus d dx of what? 2y squared equals to 0. So we differentiate it so that we find our dy dx. Like this, the whole expression is the same as saying y equals to, okay, let's just leave that side. I will not complicate things for ourselves. Okay, so when you differentiate this, this is what you're going to have. If you differentiate this one, this will be 2x. 2x. If you differentiate this one, that will be minus, that will be 4. That will be 4. Now, if you differentiate this one, this is an implicit function. When we say implicit function, that means variable y, which is the dependent variable, is inside the function itself. It's not like standing alone. So differentiating this one implicitly, that will be plus 2 times 2, 4. And 4, that will be 4 times y raised to power 2 minus 1. That's raised to power 1. So, and since you are actually differentiating a y, which is a dependent thing, you add dy dx to it equals to 0. So now we have to make dy dx here the subject of our formula. So in that, we have to take these other terms to the right hand side. So 4y dy dx will be equals to 4 minus 2x. Equal to 4 minus 2x. So that our dy dx will now be 4 minus 2x divided by 4y. 4y. So if you factor out, there's a common factor in each of these terms here. So you can factor out 2 from here. You can factor out 2, or you can still leave it like that and make use of it. Leave it. So okay, let me just leave it like that and make use of it. Make use of it. So now we'll find our dy dx. This is our dy dx. Dy dx is equals to 4 minus 2x over 4y. Which is the same thing as what? 2 into 2 minus x into 2 minus x divided by 2 times 2y. 2 will cancel 2. So finally you have 2 minus x divided by what? 2y. And so we've simplified that. So now this is the gradient of a line. This expression represents the gradient of a line tangent to this point. But what we were asked to find is the gradient of the line normal to the curve. So there is a relationship that exists between the gradient of a tangent, the gradient of a line tangent to a curve, and the gradient of a line normal to a curve. The relationship that exists is if you have m of n, that's gradient of a line normal to a curve, multiply with gradient of t, that's a line, not a tangent to a curve. The product will give you -1. This is the relationship between the two. So that if you have one, you can know what the other will be. So now, this is the gradient. This is our expression that represents the gradient of what? Tangent. Gradient of tangent. Now they said at the point, at this point, 0, 1, 0, 1. So if you substitute your 0, 1, 0 stands for x, 1 stands for y. You substitute that, you have that your gradient of the tangents to that will be 2 minus 0 divided by 2 times 1. That will be what? 2 over 2, which equals to 1. So the gradient of a line tangent to this particular curve, that is of tangent to this particular curve, is equals to 1. So in that sense, since we have this relationship equals to -1, and we know that our m of t equals to 1. So in that case, our m of n, that's gradient of a line normal to that curve, the gradient of that is our the gradient of the normal will be -1 divided by 1. That's divided by m of t. Divided by m of t, which is 1. So you give you -1. So your m of t is -1. So that's the solution. So the question asked us to find the gradient of the normal to that curve. and we've successfully find the gradient of the normal to that curve is -1. So if you check in the options of that exam, if you have it, you see -1 as one of the options, and that's the correct option. All right, take care.